can see it here. Before I start, for those of you who are not following issues related to biosecurity on the more political and policy landscape, I'm looking forward to being able to provide you with this update and to get you very excited about it, and to hopefully reach out and to be able to work with us. And for others, I guess you know these issues very well, and I'm looking forward to more of a Q&A. So what I really like is, when you have a really good presentation you're looking forward to giving, and you have a slight glitch, so I will keep on talking. I work for the International Biosecurity and Biosafety Initiative for Science. We are a foundation based in Geneva. We're independent, and we work with stakeholders across the world in a very multi-stakeholder approach, working from governments and the scientific community, etc. Our mission, I'm going to cheat. I'm just going to look over the shoulder. So our mission is about safeguarding modern bioscience and biotechnology. As I said, we work with global partners, which is going to be really key in the area of biosecurity. Here we go. Excellent. No problem. I know you wanted to test my nerves, but it's okay. What's really critical to our work is about reducing risk of catastrophic events that could result from the deliberate abuse or accidental misuse of biosafety and biotechnology. I think you'll agree with me, these are really critical themes in the context of the conference that we're having today. So I want to give you a little bit of background about two main initiatives. There are several, but two main initiatives that are really relevant to the talk on biosecurity today. The first is a common mechanism. So this is a sequence screening tool that we have, which is free, open source, and globally available. There are other such initiatives, but the idea here is really to make biosecurity accessible to all of the stakeholders in this space, and to have an opportunity to be able to use something which critically is free, and to be able to make it financially and economically viable and approachable for them. There are four main pillars to the common mechanism. The first one is really about onboarding, so it's about making sure that the customer is legitimate in the order that is being placed. When the order is being placed, we want to make sure that we identify any red flags in orders. Then we move on to bioscreening and a follow-up if that's necessary. If you want to know more information about the common mechanism, I really invite you to look at our website and contact me if I can help in any way. Another really important project that we're working on, and that I'm actually leading, is around international standards. Because while we're talking about biosecurity today, for those of you who are not fully apprised of this issue, I just want to share that we don't have an international framework or an international norm on how to manage this issue around biosecurity. So now there is a push to see how we can develop and implement international standards, because that makes sense for a whole bunch of reasons which I will go into. So here what we're really looking at is supporting common international or harmonized international standards in DNA synthesis screening, because this would help to have a better overview of what is happening, and to make sure that biosecurity considerations are implemented. So here there is definitely a growing role of synthetic nucleic acids in the bioeconomy, and that raises biosecurity questions. These issues have been talked about since yesterday. I just want to recap very quickly. So in terms of data storage, diagnostics, biomanufacturing, these are increasingly relied on, they increasingly rely on synthetic DNA and RNA. There's access to synthesis technology is becoming cheaper, faster, and decentralized. And researchers and clinicians routinely order or print custom sequences, as you know. So all of these are extraordinary opportunities, but with them come risks, and they are expanding in parallel. And this is why the issue of biosecurity is so key. We know that there are vast volumes of synthetic DNA that are being created. We know that there are risks of unintentionally creating harmful sequences, and there are therefore existing biosecurity practices that are inconsistent and voluntary. In the context of the conference today, for me, the biosecurity challenge of DNA computing really resides in the sheer scale of what we're working with, and that necessitates a robust strategy to ensure that every combination that is produced remains safe. So why is this issue so critical? Well, that's because, as I mentioned, there's no global requirement to screen synthetic nucleic acid orders. Some companies screen voluntarily, and here I really want to talk about the work of the International Gene Synthesis Consortium, IGSC, which has done a remarkable job for many years now in pushing this agenda forward, putting together a harmonized screening protocol, engaging with governments and with international organizations in a really critical manner. Why is the issue of a screening gap problematic? Well, that creates security gaps, as I've already mentioned, an unlevel playing field for responsible actors. So that means in terms of competitiveness, this really is an issue. And there's a risk of screening evasion by malicious actors. So again, why does this matter? We have challenges at the international level. We have no overarching framework to ensure coordination, and we have limited oversight of emerging technologies. I'm going to stop being really negative because, and this is not an exhaustive list, there are many initiatives that have been going on for over the years. So the United States has been a leader here, and again, the list here is not exhaustive, but if we turn to the HHS screening guidance back in 2023, or the OSTP framework in 2024, these have been absolutely critical in providing the guidance that we need in terms of biosecurity. Given that we're in the European Union, I wanted to just pause very quickly on the last line. The issues around biosecurity are live right now in the EU. So if you are living and working in a European Union country, I would really encourage you to follow what is happening at the EU level. And let me give you a bit more detail. So the European Parliament is currently discussing a first report ever on biotechnology and biomanufacturing. The date for adoption is set for the 7th of July. There is an article for the first time calling for sequence screening. So the issue of biosecurity has not been well received by the European Parliament. There's been a tremendous amount of pushback, but in the current state of this European Parliament report, there is a call for screening. There was at a time a call for mandatory screening. We don't really know what that means, but mandatory screening in the European Union, it's no longer there. But if you want to follow this issue a little bit more closely, keep an eye out on the 7th of July. It's a report written by a German member of the European Parliament, MEP, Bentele. And so I think this is going to be very important. For those of you who are really into these issues, you might say to me, yeah, but European Parliament reports are not compulsory, and I agree, but they send a very strong political signal. The other really important development is around the EU Biotech Act. So anybody actually had the opportunity to respond by the 11th of June to a call for evidence of the European Commission on the EU Biotech Act to indicate what you felt was important to be in this act. Another opportunity is Monday, 23rd of June. There is a call for evidence on the bioeconomy. You also have the opportunity to make the link there and to call for screening and biosecurity considerations. The EU Biotech Act is a very big deal in the European Union. The European Commission timeline is very tight. The idea is to adopt an EU Biotech Act in 2026. It's now become a very political file, and for those of you who are a little bit familiar with the European Union, you know that it loves to regulate. So the concerns that some of us have is that this has become a very political file, as I've said, meaning that it's more difficult to engage with the European Commission on these issues. the level of expertise within the European Commission on these issues is rather thin. And so for those of you who are working in the European Union, I would really encourage you, once again, to contact your ministries. This can be Ministry of Foreign Affairs, Defense, Innovation, it really depends. But get involved in the conversation, because come the autumn, there will be hearings, there will be opportunities to get engaged. And I think it's really critical that the European Commission hears from all of the members of this community. They're open to hearings, they're open to exchanges. So again, please don't hesitate. My contact details will be at the end of this slide, so don't hesitate to reach out if I can help as well. Taking a step back, there are international standards and guidance. So I really want to highlight the word guidance. This is super important, meaning they're not compulsory. So the WHO did adopt in 2022, you may be familiar with it, a global guidance on the responsible use of life sciences. It's currently in implementation. There are supporting documents in order to implement this global guidance. And critically, the International Standards Organization has adopted in March 2024 a standard called on the technical and quality standards for gene synthesis. But there is a specific section on biosecurity. Here is the reference of this international standard. And because I'm very excited about this, I'm going to do a very quick deep dive. What is interesting about it is that it provides a uniform general guideline. This is the first time it's happened. The scope is quite narrow, however, it's only on double-stranded DNA and providers. Sequences 50 base pairs, so that's can be discussed. And it does also cover, the issue of lab biosecurity and cybersecurity. So again, this is a step in the good direction, I would argue, because it is a global standard, and so many constituencies, for example, the European Commission will look at a standard and just implement it, etc. But the wording around biosecurity needs to be tightened up in order for it to really have an impact. So at IBBIS, we're hoping to develop a supplementary guidance document to this standard that could help to create this international framework, which we are calling for. So this is what we're doing. We are doing this also by facilitating international workshops and by mapping supplier practices. What is really critical in the work that we're implementing is, as I've mentioned, we have a multi-stakeholder approach. These are just some of the stakeholders that we're working with. If there are others that you would like to share with me, please don't hesitate. We are very keen to have a broad outreach. And I just wanted to share a case study with you, which was reported in the World Economic Forum conferences and publications just last year. We worked with Catalog, which developed a clean library where they pre-screened 30 to 50 base pair DNA components. And these, what's really important here is that these components were certified as biologically safe, allowing unlimited combinations without repeated screening. And this safety by design approach aligns with US guidelines at the time and reduces biorisk at scale. Here, Catalog used the IBBIS common mechanism that I referred to at the beginning of my speech. Sequences were screened against 4 international risk databases for known pathogens and toxins, and that meant that future encodings remained compliant with current IBBIS standards, with automatic updates and new threats as new threats emerge. So I thought it would be interesting for you to see a live study and how it relates to this conference. So I just wanted to end with a call to action. We feel that it's really imperative to engage with scientists, industry leaders, and policymakers to make the bioeconomy a collaborative endeavor, transcending borders and disciplines. looking to establish global standards and enforcement mechanisms, and ensuring incentives aligned with long-term public good. And that's it. Thank you very much for your attention.
Are there any questions? I have one question on my side. Oh, yeah, Albert.
Oh, for distributed synthesis systems that somebody can buy, how would these be kind of regulated? Would it need to be like hardwired into those instruments that certain sequences can't be made?
So are you talking about printers, for example?
Yeah, that like individual people could buy.
So the HHS guidance of 2023 does cover that particular scenario. I'm happy to report that I used to work for such a company, a French company, and we were very much engaged in the discussions with ASPR and HHS in the run-up to the publication of the 2023 guidance. And so we were able to set out what a biosecurity policy looks like for such a decentralized provider. Critical to that was really about customer screening, first of all, having a better understanding of who they were, what they were ordering, if there was a sequence of concern, and establishing the legitimacy of that customer, then looking at the orders as they were printed on the device, working with sequence screening providers that could do that in real time. The question being, is the device being used online or offline? That's really the critical point. And this company had an extraordinary biosecurity policy because they had a closed loop system in the sense that the device only worked with the consumables produced by that company. So that biosecurity was really built in from the outset.
Hi, I have two questions. The first one is, we all know that the best way to secure is to screen the customers first. This means that at one point we need to have a list of all putative authorized customers, let's say. What type of issues that brings?
I think the issue of certification is an important one. I don't know if we can blacklist or whitelist customers. I think this is a really critical point. Having worked on the issue firsthand myself, I realized the complexity of it. One of the major lessons learned that I can share is that this is really an ongoing process. It needs to be done throughout the company or the organization. I think what really struck me was the teamwork that we had instituted within this company, and working across the board, working with the IGSC members to identify best practices. But moving forward, I agree with you, we have to go with something that's much more systematic, and that would help to alleviate any concerns that stakeholders have.
And very briefly, the Biotech Act by the European Union, this is of course not only for DNA data storage, but also for synthetic biology. Can you just comment on this?
Absolutely. It's very, very broad. But I think I haven't bumped into anybody within your community during these talks. So that's why I'm really encouraging you to seize the moment, inform the European Union, and help shape the agenda so that it fits your research, your concerns, and so that you're in the driving seat. The timeline again is going to be very short, and this is a very political agenda now. And so I know that in France you're working with the ministries, and so you have a good dialogue there. But if you can work more at the European level, you have my contact details. Happy to put you in touch. Please do so. I think it's going to be really critical.
Thank you so much. I was wondering about if you had discussed challenges where, you know, you screen a sequence and there's nothing bad in it, but if somebody's purchasing or ordering many sequences that they can put together, if the combination of some of those pieces could be bad, like the last little bit of this sequence, when you combine it with the first little bit of a different sequence, that combination is bad. Like, for example, with your work with catalog, they screened all their pieces, they're good. Did they also have to look at whether they could accidentally make a bad combination? And that would be applicable to any customer as well.
I guess here what you're talking about are what we call split orders. This is definitely an issue that is on the radar screen. Again, I'm going to refer back to the IGST. I think what I've, from my time there, and I'm looking forward to James maybe intervening here, because I know he's so much more capable of responding to this question. But what I've seen is indeed how can companies exchange information to put together, you know, how can I say this, behavior that is problematic and that could lead to split orders being, so an order being put to different companies that could then be put together. And that is something that requires more communication, more knowledge about. That's, yeah, I don't know if I've been very clear on that one.
So I'm from Catalog.
Oh, good. Hello.
So we just did a complete sweep of all our components, looked at all possible combinations, did variations in case there was an anomaly in any of the components within some distance, and drew a conclusion based on that. The other thing I'd say is that we had this issue with a company we were dealing with that expressed concern about this. And I said, you know, if I really wanted to create something bad, it'd be a lot easier for me to just do it on a benchtop somewhere in a university lab than screwing around with trying to do something and manipulating the components that we have in our library. So it was pretty straightforward. Computationally non-trivial, but I only had to do it once. So it took about a day. And, you know, the combinations were quite large in number, but I just had to do it one time. So it's one of the advantages of doing encoding by assembly. You're not incurring novel sequences every time you do an encoding.
Other questions? I have a comment on this. We at biomemory, we are also using pre-synthesized sequences, so we can design, and this will be part of the discussion most probably after James' talk, or during the panel this afternoon. There will be a long panel discussion about biosecurity and biosafety. So, but with pre-synthesized DNA sequences, you can design the sequences so that they are not harmful even when they're combined. And I have another question, is on a 50 base pair limit. So it means if I want to make a virus, I just order 49 bases sequences and I can do it.
Yeah, I think for the ISO standard, there were a few raised eyebrows. You know, for example, they're only looking at double-stranded DNA. I, for one, am very enthusiastic about the ISO standard because I think it's you know, we're moving in the right direction. We at least have it on the radar screen. There is appetite within the International Standards Organization to look at this and to work on it more. And I just, if we, you know, think back to this slide where I had all of the developments happening around the world, there is an extraordinary momentum on this. I think if you'd asked me to do this presentation 2 years ago, it would have been super quick. Now, you know, we have to be vigilant of what's happening everywhere. I've spared you what's happening in other countries, but for example, even in ASEAN, there's this declaration from October 2024 on strengthening their biosecurity and biosafety. So this issue is really live, and that's why this may not be top priority for you, but I would really encourage you to talk about it with your colleagues, figure out how you can join the conversation, get on board, and help shape the agenda, because probably where you're working now, there's something going on.
Thank you very much, Sophie.
Thank you.